Welcome back. In this video, we are going to talk about how estimations are done for Agile projects. In Agile, the most widely used technique for doing estimations in Agile, we call it as a relative estimation technique, where we basically compare two items against each other and arrive at what should be the estimation of a product backlog item which you are estimating, right? For example, say you are having one user story which is of size orange and one user story which is of size grapes. So, whenever you are estimating a new user story, you compare against these stories and arrive at whether the new story you are estimating is of size grapes or orange or is it watermelon, right. So, like that you can compare against each other and arrive at what should be the size of your new story, right. So, that is how agile estimations work, right. So, this technique is called as relative estimation technique. The reason why we use relative estimation technique in Agile is generally for end users or generally in terms of estimating any work, right. It's easy for us to compare two things and talk about which one is bigger, larger, or which one is lighter, shorter, or whatever you call, right. So that way it makes easier for teams to really understand and go about estimating the work which is there, right. So there is a natural human tendency to compare things and talk about what is requires more effort and what requires how much effort, right. So that way agile relative estimation techniques helps not only in estimating your user stories or requirements very quickly, it also helps you to really be as closest as possible. The reason being you cannot translate the exact number of hours which is required to complete any given work, because number of hours of work for estimation is something which has been tested, which has been seen that many a times it fails. So it's not true that if some task today, if it takes me 10 hours to complete that task, the same task if I start working tomorrow, I might be able to finish either in 10 hours or it might take me 20 hours. So it entirely is a contextual in nature. So that's the reason hours of based estimation, it takes long time to really arrive at what should be the number that should be given to complete a given particular requirement or a task. So to make it easier, relative estimation techniques can be used, which helps you in quickly sizing your product backlog items by comparing each and every work item against each other. So here is another technique which is called as affinity estimation technique, which can be used in estimating your product backlog. Here as an example, we can take about the t-shirt sizes, where XS means extra small, S is small, M is medium, L is large, right. So you take all the requirements from your product backlog, categorize them into these buckets, and this is another way of really estimating your product backlog items very quickly, and it also gives a kind of understanding in terms of what is the effort that might be required in order to build a given product backlog item, right. So this is another way of actually quickest way again, if you are having hundreds of backlog items to be estimated. So this is one of the easiest and quickest way in which you can organize the product backlog items into different buckets, and then you can estimate your story. Now, what does an excess mean for one particular team may vary from what does an excess mean for any other agile team, right. So you have to understand that two different teams, you cannot compare the story points between two different teams. So that's not the way it was supposed to be designed. This brings us to the end of this particular video course where we talked about agile estimations and briefly gave you an example with respect to relative estimation technique and affinity estimation technique. Hope it was useful. Again, the estimations, right, you cannot be accurate with your estimations. So there is no point in spending a lot of time in estimating your product backlog items. So Agile emphasizes more on relative estimation technique and affinity estimation, where you can relatively compare against each other and quickly do the estimation exercise and go on with the actual development of software.